Good afternoon, and everyone. My name is Bruno Son, an associate professor at Geomatics programs and in Lasson School of Engineering and York University. So I'm very happy to welcome you here today on behalf of the Geomatics engineering programs at York. And we're very much delighted to have you participate and share in our fourth GeoTalk virtual seminar series. And thank you for joining this meeting today. And I'm going to introduce a little bit of background to start the exciting presentation. And Geomatics engineering programs in York and University was founded 19 years ago. And we will have a 20th birthday this year. And for almost 20 years in the past, many geomatics undergraduate and graduate students have been educated through our programs, who are now leaders in various fields of geomatics areas and as engineers, entrepreneurs, and opinion leaders and educators. And our programs has also preliminarily contributed to geomatics research community and industries by conducting innovative research projects over the past few years. And GeoTalks is a bi-weekly seminar series organized by Geomatics engineering programs at York and also jointly Canadian Institute of Geomatics Toronto branch. And this series will host industry leaders, entrepreneurs in geomatics. This is a great opportunity to hear from industry leaders in geomatics who will introduce their cutting edge geospatial technology through this seminar series. Today, we are honored to have Stephanie Michaud with us today. And Stephanie is a strategy marketing manager for the field software solution segments of the Geospatial group at Trimble Inc. And she is responsible for activities related to market research, business partnership, product development, and new product introduction spanning GIS and Survey product portfolios. During her 9 years tenure at Trimble, she has also held technical roles in the land administration and agricultural groups. And Mrs. Michaud holds a degree in geomatics engineering from University of Calgary in Canada, and is a registered professional engineer. So in her talk today, Stephanie will share her visions and experience in Trimble and prepare yourself to be challenged, excited, and inspired today. Okay, so Stephanie, so it's now the microphone is yours.
Wonderful. Thank you, Guno. Let me just share
your screen now.
Yeah. Wonderful. And thanks everyone for the opportunity to present to you today. It's wonderful to be a part of York U's activities. As Guno said, I'm from the University of, I went to the University of Calgary, so to be present on the East Coast with you guys is a rare treat, and I'm excited to be invited. So we'll get right into it. So, I mean, Guno already did a great job of introducing and giving the run up. Since that we are all in 2021, I'm now entering my 10th year of tenure at Trimble. And I'm based in Denver, Colorado. So yeah, in the Mountain State, just south of you guys. But I've worked for Trimble in 3 different countries, actually, both in the United States, in Canada, in the Vancouver office, and also in France in the Paris office. So I have some global experience working as well, at least being based in different locations aside from just project work. I've made the trajectory from being an engineer on the technical side, doing more development work, all the way through to, as Guno said, more of the marketing and strategy piece within the company. And so we'll get into a little bit more about my journey and how my career progression was a little bit later, but I've had a couple of different roles, but all related to geomatics and how they apply, especially at Trimble. So yes, I'll talk about geomatics at Trimble because I'm sure many of you are interested in what you're learning today or what you are currently working on, how that plays out in industry working at Trimble. Specific to my career, I'll share some examples of things that I've worked on, leveraging my geomatics expertise. And then also some really cool applications that are relevant today And where I see the future of geomatics going, especially as it relates to the projects that we have going at Trimble, but also I think as a whole in our industry, what are some of the really important aspects that geomatics brings to our modern day technology offerings. And I believe we're doing Q&A after, but then if there are questions that come up as I'm going through, feel free to put it in the chat, and we'll save them for later. Good. So geomatics at Trimble. I mean, Trimble is a large company, and it's really, geomatics is the foundation of everything we do. It's really quite incredible to think that such a large company, when I was in school in 2011, when I graduated, I thought geomatics was a niche part of our industries, and it's really just exploded in the last 10 years. I put this slide up here just to give you an idea of scale with Trimble. With we have 2,000 unique patents, of which I'm a holder of one. A lot specific in construction and technology patents, also in the agricultural space. So we do a lot of R&D and investigation where geomatics knowledge is really the core part of how we're able to innovate in what some might consider traditional industries. And we're also talking about a broad amount of people. So there's 11,000 people at Trimble across 35 different countries. So it's just incredible to know that a company with a footprint like that can leverage and harness the power of geomatics on a daily basis as part of their livelihoods. I love this slide because I think it not only talks about Trimble's transformation and the impact of innovation in the geomatics space, but it also talks about in our industry, what I think our industry as a whole is undergoing this transformation. You start with GPS as like a foundational concept and technology. Charlie Trimble, Trimble's founder, famously called it the fourth utility, envisioning it as the fourth utility for the everyday person. So we start with that. We add in positioning technology through total stations, optical instruments, laser, and then scanning and imagery components. And then you go into looking at productivity components. So once you couple those two things together with your positioning, knowing where you are in time and space, and then being able to know that in a very acute sense, now you can begin looking at how can you optimize and really make things more efficient and ultimately bring together integrated pieces of a workflow. And so that's been the journey with Trimble. We started just providing GPS to people who wanted to land surveyors who needed to know where they were and didn't want to rely on optical instruments all the time. But now we're talking about really transforming the way the world works. And so the title of my presentation today is also the company mantra. And I think it's really true when you think of all the different applications that geomatics serves today. It's beyond just knowing where you are, like that construction surveyor that you have in the middle screen there. But on the left side, understanding where to dig, how deep to dig, how fast to dig, what you're digging, where did what you dig come out of there, what's there now. And then on the right-hand side, in the agricultural context, what's the overlap between your pass to pass with your tractor vehicle? Are you crushing crops on the ground? I mean, all these things are more than just knowing where you are. It's an application of that. And I mean, when it comes to the role that geomatics plays, I mean, the possibilities are really endless. And, of course, traditional surveying methods and practices are the foundation of what the majority of our development teams are relying on. But then there's also the GIS component and database handling and management of attribution and understanding what is there with those points, not just where they are. What is that interesting information that makes them relevant? And then aerial, terrestrial, unmanned, drones are the hot topic, of course, of recent years. Being able to handle all of that information that it's acquired through imagery and being able to process that into applicable models or representations of project progress. And then combining that with extraction to understand pieces, measuring tools there, photogrammetric extraction and algorithms there also feature identification is also a huge part. GNSS, inertial, I mean, we've been talking, I know what I've done a few lectures before on talking about how do you incorporate autonomy, how is autonomy changing, and what are we doing at Trimble related to autonomy. And that sensor fusion component of combining GNSS with other types of sensors is essential to really getting to a true autonomous state for vehicles, both on a consumer and professional grade. And then moving into 3D modeling and visualization, augmented reality is another cool hot topic of late. And so being able to actually do the modeling from the imagery, position it in space in an accurate way is another tool. And then building artificial intelligence off of that in order to simulate scenarios becomes a whole other aspect, right? So, I mean, these could be titles of your courses you're taking now. All of those apply and are all core geomatics concepts that apply to the work we do at Trimble. So some great examples pulled from across our company. So we install and offer software and services for truck hauling companies for automation of their driving routes, automation in the sense of telling them exactly where they need to go based on the load they're carrying. So if they have hazardous materials, it's automatically scanning and searching databases for where are trucks of that dimension and size allowed to travel with that type of hazardous material load, and that they can fit under specific overpasses, for example, on their route. And then what is the most efficient way to get there when you take in all those factors, right? We also provide safety cameras so that drivers, if they have to get out of the vehicle, say on a mountain pass to put on chains, they have video cameras on their vehicle and then also on themselves. So from a safety standpoint, they can see what's going on even when they're putting chains on their vehicle. Some of those are just an example there from our transportation sector. And then we have the concept of building information modeling or digital twin creation, right? So being able to, this is actually my office in Westminster in Colorado. This is our second building on the campus. And here you can see all of the constructible models that contribute to that building. So whether it's HVAC, concrete foundation, electrical lighting, plumbing, that's all here in a model that you can zoom in and out of, turn layers on and off of, take measurements, place furniture, place equipment, determine how many people could actually fit on a particular floor. I mean, building information modeling, BIM, is a huge topic and something our buildings group and architectural design group spends a lot of time with. And you might be familiar with the product SketchUp. All SketchUp models are another great way of a little bit more of a lightweight way of representing digital twins. And then from our construction group, so applying positioning technology and inertial sensors, combination of different sensors for safety applications, but also for just getting the work done more efficiently. So here they're laying asphalt and they're doing it on the correct location, but also at a perfectly level grade, right? So being able to measure it level the first time, as opposed to going back and having to smooth it out, or even ripping it up and having to go again. So being able to measure that and have the machine do that intuitively instead of having to go back manually and repeat the process several times. Here from our railway division, using our GATO sensor. So railway lines, whether it be for heavy freight or for passenger commuting, require inspection to make sure that they're perfectly level and that when there's shifts in movement throughout, as are naturally occurring, that the tracks still maintain their integrity. And there's a really specific and small tolerance on railway lines, especially when you get into high-speed trains in Europe and Asia. So our GATO sensor travels each railway line and is able to detect tiny, tiny fluctuations in the railway lines, both parallel to each other and then also overall. So providing profiling there in the rail space. And then tunneling. So we use our optical instruments, and this is from our tunneling and monitoring group within Geospatial. So tunneling is used to measure once you're underground, of course. You don't have GNSS to assist you down there. But you can imagine that when you're starting a tunnel, you can start from one end or from both ends, either end, and you want to make sure they meet in the middle, right? Not that you are missing each other in the middle as you're excavating. So being able to track to the same line as the progress is happening and minimize the amount of earth moving and do it so in a most efficient way as possible. And from our forensics group, this is one that has, when we talk about scanning and 3D models and the importance of high quality and high density point cloud data, this application is just incredible. Our forensics team uses RSX10 scanner, which is a total station and scanner combined into one. And they will scan accident and crash scenes at the time when they arrive on site. And that way they have a digital record of everything that transpired at that location, and they're able to move the wreckage much faster than they would otherwise when they're having to take manual measurements and document. It just takes one piece out of the equation, and then they're able to review all that later and measure, for example, how far did the tire travel from the flipped car? They can measure that in the model. They don't need to do that in the space. Sorry. Pardon me. Everything good to go now? I just want to make sure.
Oh yeah.
Yeah. Okay.
Yeah.
Good. Yeah. So you can imagine that the applications that has for not only safety of the officers and first responders that arrive on crash sites, but also for consistency and repeatability when it comes to ensuring that the data is captured and it's maintained its integrity throughout the process. As when it's brought to trial, for example, it could be months or even maybe years later beyond when the actual accident occurred. And this is a newer partnership that we announced with Boston Dynamics related to robotics and automation. And so this is using the dog robot here, which the idea behind this is coupling, again, scanning total station optical instruments for indoor use so that in situations where it might not be safe for a person to walk in a site, whether that be due to exposure or now in the time of COVID, we can't have people that are in close quarters, you can send a robot in on your behalf to do inspection of a site facility, and it can take the model and scan it for you as well. So really cool application. We have one of these robots in the office here in Colorado, and it's almost creepy how lifelike it is and how it responds to whether it's smacking into you or hitting different objects. It responds very well. So those are just some applications related kind of across the Trimble group. I wanted to share more specifically about, in my career, some my progression and things that I've kind of learned throughout the way, and also some cool projects that I've worked on. I've had the benefit of working in a lot of different groups at Trimble, which has been great, just to gain a lot of different exposure. But I started at the University of Calgary in undergrad working on software design and doing GNSS observation calculations and refinements for autonomy back in my undergrad, which was my first job, and helped me become a better programmer, which I think is probably one of the biggest skills that we learn in geomatics in an applied sense, as well as a true learning the language and efficiency sense. But when it comes to new students approaching the world of geomatics and careers in that space, I think programming is so essential for success in the future. And I was fortunate that when I came to Trimble, I started in the rotational development program, which helps students who have recently graduated gain exposure to a lot of different industries. As I just showed you, you can imagine there's a lot of applications of geomatics, and it's hard to pick which one you're interested in, let alone you don't even know what's possible when you get started. So I was able to do 4 6-month rotations where I worked in mapping and GIS. I work in our survey group. I also worked in agriculture and then our imaging group with some of our UAVs. And that gave me a really broad perspective on what I might want to spend more time working on. And out of that, I decided to work full-time in our agriculture group, being our technical solutions manager, which means I was in charge of making sure the GNSS, the correction services, the displays, the actual steering systems, all of that that works together on a tractor actually does work as it should and achieves the high accuracy that they need for some applications. So that was a really interesting, eye-opening time for me. I had no background in agriculture whatsoever, but coming from Geomatics, I was able to really think critically about how we were taking all these systems together and apply it in a way that I wasn't used to thinking through. And actually that was really fruitful for me because through just asking questions and again, applying the knowledge that I had, I was able to create and file a patent through Trimble there in the agricultural space. So it was really, really fun for me. After that, I wanted to spend some more time working in the sales side of our organization. So working in business development. And specifically, we had a need in our land administration group, which is related to securing ownership and documenting title and record within a cadastre. So I did not focus on surveying when I was in my undergrad. I focused more on the GNSS side. So I had taken land tenure classes and also done some surveying work as part of coursework. But for me, jumping into this aspect of our business was also very new. And also being able to work and travel throughout Latin America was a really great growth experience for me, working in a second language and then also working in just a diverse range of locations where the infrastructure we take for granted in North America is not present. So oftentimes it was a greenfield exploration for installing and equipping areas with GNSS infrastructure. During that time, I was also then, I was able to become a professional engineer with APEGA in Alberta. So that was great. I also moved back to Canada for a little bit to work out of our Vancouver office. And that was a really nice time for me to just be back in Canada for a little bit, having been in the US for almost 5 years at that stage. After working in sales, and this is kind of common what happens when you've been out in the field for a while, I had all these ideas about how to create better products for our sales team and for our customers. So then I moved into a portfolio management role where I was helping drive some of our engineering development teams to create products based on insight that I had, but also from a lot of the projects I had worked on. And for that, I also, I moved to Paris to work there with our development team that was specific to working within land administration and be closer and in the same European time zone. So it was a great opportunity for me to work with our European teams. Yeah, and then after that, I relocated back to the United States, where I took on a role now working within our survey team, working on our field software. So anything, Trimble Access is our flagship product, but that also includes other products that related to surveying, mapping, and GIS. And so I'm responsible for the strategy and direction of those products and how they all fit together at Trimble. So, you know, I started very technical and I kind of bounced around, but all through the way, there's a spot for a geomatics engineer for sure. So some great applications that I had a chance to work on myself. So in agriculture, I mentioned already like the patent filing and certifying of the patent. I want to show you this photo on the left here. Those rows are so accurate. They have about a 4 centimeter accuracy here are those rows. Being driven by a huge machine, right? And put in the ground each year. It doesn't matter which vehicle is going there, but they can guarantee that they have that accuracy. Because in those mounds, that's where they plant carrots or perhaps like sugar beets or high value crops, right? That need to, or potatoes that need to be buried in the soil. And so they need to be able to come back and during harvest time, for example, and be able to chop the right height or depth into the ground so that they don't chop the carrot in half, right? No one wants a half carrot. They want the whole carrot, right, in the bag. So the level of precision involved in like agriculture and making sure food is farmed and maintained and grown and then ultimately harvested is just astounding. And so working in that space and trying to creating tools and products that optimize steering and terrain modeling was part of my work there in ag. So in the land administration group, so in Colombia, I was fortunate to be the project lead on a technology solution for establishing land ownership rights and documentation for rural landowner, rural province in Colombia. This was an incredible project, and so many challenges being rural and very remote, no infrastructure in place, people who need to be able to articulate their land, being able to give them the ability to say, this is my piece of land and I own this, and then receive a document certifying that. It's just absolutely incredible. So really cool project there of applying technology where it did not exist before and things were just drawn on paper with pen and paper, right? Also in the DRC, we sponsored and worked with Cadasta, which is related to, they also help to document human rights to land and also to public resources, in this case, water. So here working with the Cadasta team to help document where water sources are, and then where the riparian access rights are, and then how they're managing how water is allocated to different communities. Another really rewarding project, and being able to offer a low-cost solution in this case really made it possible. Also, as part of a joint project that Trimble sponsored with the International Federation of Surveyors, or FIG, I was tasked with helping provide equipment, both on the ground, so survey rovers and optical instruments, as well as in the air. So in the air, in the sense of imagery acquisition, but also image processing and algorithm development. So I was part of this team that was using different geospatial solutions, some provided by Trimble, to help identify and create feature extraction for identifying plastics. Not necessarily, it says oceans here, but really it's more on beaches or river deltas and estuaries. So being able to identify where there are particular types of plastic and then supervise the removal of it in an appropriate and fast manner. And more recently at Trimble, we launched the Sight Vision product, which is an augmented reality tool that's low cost, which allows you to really visualize your geospatial data on site in a way when you might not be able to interpret it elsewise. We often are working with professionals who maybe they can't look at a map and immediately see the building pop up in their mind. Not everyone's spatially orientated like people are in our business. And so I love this tool for the ability it gives everyone to just be able to envision how we will change the landscape around them with geospatial data. And then also in North America, well, in particular, the United States, the NGS is adopting a new datum. And so I've been working with the team within Trimble to ensure that our products and our coordinate system transformations and our office software is able to handle this new change, which is obviously involving a lot of surveyors around the world and affecting how their past projects and current projects and future projects will operate and be processed. And so also another more technical office side project where requiring a lot of geomatics knowledge, coordinate systems, geodesy, foundational for sure. So those are just some experiences that I've been a part of and in some cases led, and been really rewarding to use my geomatics expertise there. And so coming to the future of geomatics and where I see it fitting into the tech industry or tech space, even just in general companies. I think the future is incredibly bright and rewarding. And I think more than ever, industries need geomatics. And in this time where everyone has a connected phone with a GPS in it, everyone has ability to connect all their devices in their home through IoT. They have cameras on their front of their home to identify when people are walking by. I mean, all of these types of products are leveraging aspects of geomatics, and expertise in that area is becoming more and more important. I often I'm in charge of a lot of our business partner relationships, And working with partners, they might have a really unique idea or application, but when it comes to getting that accurate position down to the centimeter, or in case of like some monitoring applications, sub-centimeter, the knowledge that it takes to create software or hardware products that actually are capable of that in a reliable and repeatable way, that's a really unique skill. And being able to articulate that also in a way that that makes sense to a consumer, not necessarily a professional, is also a skill. So when, you know, all of you being geomatics professionals, you will have that, you will occupy that space, which is very critical to a lot of applications we're seeing today. Something that I can think from just a consumer aspect, right? Like we think of delivery and how important it has been to stay home and order things online and have them be delivered and expedited. Someone might say that a company like, or a postal service might say they're having trouble meeting deadlines for delivering packages on time because of they can't locate addresses correctly. I mean, if you think about that, that's a geomatics problem. Like, is the addressing wrong, or is it just hard for the person, the delivery worker, to actually find the location? Both of those can be solved using geomatics knowledge. And if you can get that more accurate, then it becomes, perhaps you can then make it more efficient and deliver parcel packages on time and handle a larger volume, right? In order to get to that level, that kind of next level of that integrated work process, though, that's going to require the embedding and integrating of a lot of different technologies. And that's where I really see geomatics engineers playing that role of transforming those work processes today, that maybe they're archaic or it was just the way it was always done before, but times are forcing us to change and be more efficient. So I listed kind of these 3 points here about, geomatics is essential to be able to have that repeatable and reliable position, being able to communicate that position with a level of integrity and confidence, and then the embedding and integrating of all those technologies together is the other piece. And that's where I see the direction of it going, of geomatics and what professionals in the space can add. And as a natural result from a more even more simplified version, I think it's important for us all as professionals to be able to maintain our level of communication in the sense of verbal communication, but also in the sense of being able to communicate in platforms like through programming languages and being able to understand at a very detailed level how all of our products and all these technologies interface together. And on that note, I have to put a quick plug in here. If you're interested, we have many different positions open at Trimble, both internship for new graduates and also within our GNSS engineering team. So if any of this sounds interesting to you, you can contact me after, or you can look on LinkedIn. All these positions are available on LinkedIn. And there's a lot of different range of skills required, but all of these jobs are for geomatics engineers. And so with that, I'd like to say thank you for having me. And I would love to take questions. And I'm always open to connecting on LinkedIn or through email. So please introduce yourself there. Let me know that we connected here on this platform, and I'd love to chat further. But otherwise, I'd love to answer questions if there are any.
Right. Thank you so much, Stefan. Right. Mm-hmm. Yeah, it's a great talk. It's very exciting. And well, as explained before your talk started, right? I'm going to collect the questions from the audience, and I'm going to deliver it on behalf of them. Would it be okay?
Mm-hmm. Yeah.
Right. So if anyone have the questions for Stephanie, and could you write your question in the chat box? Mm-hmm. Okay, so then I can deliver the questions to her.
Yeah, that'd be great.
Okay. In the meantime, and you're showing some sort of steering optimization, so requiring 3 centimeter for agricultural applications. And why 3 centimeter accuracy required? And is there particular reasons that high precision?
Yeah, I mean, typically it's in that range for our satellite delivered sources. So our RTX service is generally in that 3 to 4 centimeter range. So that's the most common because it requires the least infrastructure to cover the most broad range. We do have some applications though that are using virtual reference stations, VRS, or cellular delivered corrections, and RTK as well, radio delivered for more localized regions. And then those are obviously in that kind of 2 centimeter range.
I see. Okay. Thank you so much. And I have a couple of questions now. One of the questions about the geoid changing. So what are the changing about the geoid in the US? I think it is from the Tristan.
Sure, Tristan, yeah. Tristan, I think the best way is to go to the NGS website to find the entire documentation on that. What I can explain is that they're updating the geoid model to be able to reference just as an update from the shifts and changes that have happened over the years. So, I mean, as we know, nothing is ever static, right? And so the model is being updated, and as a result, there are finite changes, and depending on which part of the country you're in, it's more significant than others. So previous data to this change will be affected in that if you were to perform post-processing on it with the new datum, you will end up with different result from before. So there's much more detail available online than I can give in this call, though.
Thanks. Other questions from Costas, and could you please comment further on robotics type mapping, autonomous mapping, aerial terrestrial platform?
Sure, yeah.
And so I guess the questions about the Trimble's current technology demands on that.
Sure. Yeah, thanks, Costas. Yeah, so so at Trimble, we have actually one autonomy group with 2 focuses. We call it on-road and off-road. And so on-road being like for consumer, like for vehicles, and that type of technology is more related to providing services similar to like OnStar, for example. So correction services that tell the vehicle like where it is, and then that can be reported for safety purposes. Off-road is what we more typically think of with the examples with tractors steering themselves, or also with some of the mining haul trucks, say, that are working in remote mines in like northern Canada to haul diamonds out of pits and stuff like that. So as far as what products we offer, I mean, it's a combination. It's often an inertial unit coupled with GNSS, and in some cases also steering technology that is applied, either installed at the factory of the tractor or vehicle manufacturers. And then there's also the aftermarket part of adding in GNSS and inertial sensors, plus all the software in a display that actually computes and displays that accurately. And I should say also from an aerial standpoint, Trimble used to manufacture our own UAVs, which I was a part of testing and certifying with the FAA years ago now. We no longer manufacture them. We divested that part of our company. Instead, we partner with Airbus, with DJI, and also with Gatewing. So we've kind of outsourced, you could say, the manufacturing of that, and we focus more on the software component, photogrammetric methods, and that's all done in Trimble Business Center today.
Thank you very much.
Yeah, of course.
Good. Right. So the following up questions, from undergraduates, Christian, and there's such a diverse and in-depth skill set required for all of the areas within geomatics. How can one acquire them before getting job experience in them?
Yeah, I mean, that's a great question. I mean, there's a lot to learn. Sorry, was I gonna?
No.
Okay.
It seems like an overwhelmed.
Overwhelmed, yeah. Yeah. Well, I think that So I think, yeah, as far as acquiring all the knowledge, right, your undergraduate degree in geomatics will give you a lot of different concepts in theory, right? And hopefully your professors are able to weave in applications and examples of where that's used. I guess my advice would be to pick an area that you're most interested in and try and get a job or summer job or internship or informal training that gives you some more exposure to that. And then to help build some of those skills, right? So if you're interested in GIS work, in analysis, and say like looking at different data, there's ways to take courses online to get more exposure into that. Same with programming. And then as for like surveying or photogrammetry, like looking for jobs that give you the hands-on experience is always important. But I think like when you're in school, a great way just to kind of, again, keep tying that back to industry is to inquire with your professor or through industry groups that your university might offer you connection to just kind of ask like, I'm learning about this in school. What's the real life application of this, right? For me, it was always hard until I started getting into the geomatics courses, like the start of engineering, I was like, where does this I don't understand how this makes sense. Like, I think of when I first started to learn least squares adjustments, I was like, I don't understand why this makes sense. And then you get, epochs, thousands of epochs of data of GNSS satellite observations, and then you understand why you need a least squares adjustment, and then it makes sense, right? So I think that's where the applications are important to help you understand more of the concepts that you're learning in school.
Okay, thank you.
Yeah.
Once again, how would you describe geomatics to simple folk people, to high school students, and to attract them to the geomatics engineering program?
Yeah, that's a great question. And I would say, like, when I'm meeting new people, I generally say that depending on how I'm meeting that person, I will typically explain that it's the science of where you are, and how you get there and what you do once you're there. That's probably the most generic way. And often, not now, but I used to travel a lot, and I would take, for example, Ubers pretty regularly to the airport. And I think everyone can relate to the situation of the rideshare where they pick you up on the wrong side of the street. And that's a great example of where geomatics engineering can help you find the right side of the street. If you're looking for an application to explain kind of what we do.
Okay. Okay, so the question continue. And from Marian, I think, and I would like to know, what do you suggest to a researcher to work on as a skill during his PhD that can bring more job opportunity for future?
Okay. Yeah, I think, well, I want to, that's an involved question for sure. And without being cliche and saying things like you should work on autonomy, for example, because I feel like a lot of people are focusing on that. And that's just kind of the buzzword of late. I think things that are really interesting to me right now are things like working in either how do we maintain, integrity from a geospatial data sense in challenging environments. So, I mean, I think the final frontier is indoors. So, as I talk with the example with the Boston Dynamics robot, right? Like, how do we ensure from a safety standpoint that people are able to work in challenging scenarios and still capture quality data, right? I think there's, especially now, as we have not only, I mean, before, unsafe scenarios could be it's a gas plant or a tank or an area that's radioactive, for example. Now we have things like people can be risks to each other through things like COVID, right? So how can we make sure that people are still able to continue their jobs safely, but capture information that's essential to their work? So, you know, I think that would be an interesting area to pursue, to continue to look at how you can ensure that quality of information is possible.
Okay,
Mhm.
right. So I have a few questions, and
Sure.
if you don't mind.
No, not
And
at all. Mhm.
so I know the Trimble in providing sort of like a platform and for the data analytics, right? So
Mhm.
could you explain a little bit about the Trimble's technology around the data processing pipeline?
Sure. Yeah. Yeah. So across Trimble, we have a horizontal product called Connect. Very simple. But with the premise being like, is it possible to connect all of these different life cycles or stages of data capture together, right? And ideally, there's many different people from a lot of different backgrounds. And so the Connect platform is designed to be web-based and a way that people can upload and download data from a repository, and then they can also apply tools to that data without ever needing a specialized software on their server at home, right? So the Connect platform is one way how we've done that. And it started in our building and construction group, just because as I was explaining that example of the digital twin in the building site for the office here in Colorado, you can imagine all the different contractors involved on a construction site and how many different, each one is probably having their own unique software that they prefer or that they happen to learn in school or that, their mentor trained them on, right? And ultimately on a project site, all of those things have to come together and they can't be off. They have to all be using the same reference frame, and they have to also be working within the same accuracy, precision tolerance, at least, right? Or at least the same framework and specification. And so the Connect platform evolved from that group around how can we make it easier to collaborate between those groups, because errors and mistakes are always time consuming. And if we can minimize those, then the project can go a lot smoother. So Connect evolved from that. And as we work through different groups, so of course, the Geospatial group, which I'm a part of, ultimately does the first survey for the land before it goes to a building construction project, interfacing and adding each group into the fold of Connect. And that's a big initiative within the company. It has been and continues to be going forward because it's no easy task. That would probably also be a great way to, a great topic to study in your graduate thesis around how do you handle those volumes of data in a way that's efficient and accessible, not just from one project site, but around the world, right?
Okay. And okay, so I have another questions from Mohammed.
Mhm.
And thanks for the nice webinars. I think you mentioned that you design your own drones within your group. What exactly do your group focus on designing drones? I mean, flight control, bodies, or control, etc. I think you're saying outsourcing now.
Yeah, so at the time so in 2012, Trimble acquired a company that designed their own drones. Yes. And I was part of getting the certification for flying those in airspace. So that was part of what I worked on then. In 2017, I believe we divested that company. So we no longer design them. We rely on other people to design them. And then we're more focused on the data coming from them. So we have agreements with them for being able to extract data from those sensors and then process it accordingly.
And one question from my side is, the geomatics companies such as Trimble is supposed to be developed and meet the very high accuracy and precision engineering grade precision accuracy.
Mm-hmm.
And but now the sensor getting cheaper,
Mm-hmm.
and a lot of other companies, non-geomatics engineering companies, they offer much cheaper but still dirty, solutions, right, for positionings, measuring rotations,
Mm-hmm.
and such things. And however, they achieving the very high accurate the surveying by using redundant solutions, right? So how you see non-geomatics manufacturing? Does it make sense to you?
Yeah, like in the sense of people who are not geomatics experts creating products for geomatics professionals or for consumers.
There are certain areas where these two bodies are competing each other, and
Yep.
right. So how your companies at Trimble actually want to penetrate this sort of little less accurate sensor market as well?
Yeah, so within our group, the geospatial group in particular, like we, of course, have configurable products that are available at different price points and accuracy levels. So that's kind of one way we make our products more accessible. But a great example that I shared, the one in the Democratic Republic of Congo, the DRC example with the water management, that product, our Catalyst soft GNSS receiver product, is actually designed to be a low-cost tool that can work with a smartphone and give you that high accuracy. And so we still are addressing a lower cost market, and we've made some innovations in order to do that. And one of the things that I do in my job today is actually working with partners like Cadasta was one partner in that example, who are designing a Android smartphone app, and then they pair it with the Trimble receiver, and then they're able to have a low-cost GNSS solution. Is it the only low-cost offering? Of course not, but that's just kind of the reality, right? There's always going to be competitors, but that's the one way that one of the ways we're entering, I guess you could say, the lower cost, sub-meter accuracy market as opposed to professional centimeter level.
So the last is, you mentioned about internship and sort of graduate exchange program. So how the students, our students can find those opportunities and apply to where?
Yeah, so the easiest way to find them is on the trimble.com website. We have the careers section where those are listed, and there's a specific tab just for students and recent graduates. So that would be an easy way to find it. Elsewhere, you can find it on LinkedIn. If you search Trimble and look at the open postings, they're also all posted on LinkedIn. And if you want, you can also email me, but I would prefer you go to those two as well.
Okay.
Yeah.
Thanks for the information. So thanks a lot. And okay, so is there any other further questions from audience? Right. Okay, so right. Okay, so thank you so much, Stefan. And right, so I very much appreciate for your times and exciting, excellent presentations to us. Okay, thank you so much.
Oh, you're most welcome. It was my pleasure. Thanks everyone for your time. Okay,
so right, thanks everyone for attending this webinar series. So see you at the next webinar series 2 weeks after. Okay, thanks. Bye. Bye for now.